Good morning to all. Let us start the chapter Hydrocarbon from the chemistry of ICC board school book. Hydrocarbon. Hydrocarbon is hydrogen plus carbon combined. We'll get so many compounds like aliphatic compound, open chain organic compound containing carbon hydrogen only. Therefore, their name is hydrocarbon. The molecular formula will be CXHY, where X and Y are whole numbers. The main group, aliphatic hydrocarbons, are divided into two main groups. What are that? Saturated hydrocarbons. Another is unsaturated hydrocarbons. Saturated hydrocarbon means only alkane, single bond. Unsaturated hydrocarbons which contains alkene, double bond, and alkyne, that is triple bond. The first one is alkane. The name is paraffin. This is saturated hydrocarbons which contains single bond, carbon bond is single bond, single covalent bond. The general formula will be CnH2n plus 2 in case of alkane. The first member of this series is CH4 methane. The second member is C2H6, putting N is equal to 1, 2, 3, 4 like this. And C2H6, this is the molecular formula of ethane. This is the condensed formula, and the structural formula is like C. You have tried in this case having single bond carbon and 3 hydrogen this side 3 hydrogen. This molecular formula is ethane having single bond. The IPAC name is ethane, common name also ethane. Now come to the alkene, that is olefin. Olefins, okay. Alkenes, other name is olefins, which is unsaturated hydrocarbon which contain double bond, double covalent bond. The molecular formula is CnH2n. No corresponding alkenes are there because minimum 2 carbon required to be double bond. Therefore, C2H4, putting N is equal to 2, C2H4 it will be ethene. Same process we will get propene also. The IPAC name of ethene C2H4 is ethene. Common name is ethylene. Now come to alkyne. Alkyne, which is unsaturated hydrocarbons, contain triple bond, carbon triple covalent bond. The general formula is CnH2n minus 2. Minimum 2 carbon required to be triple bond. The first member of this compound is C2H2, that is ethyne. The molecular formula is C2H2, and this is the structural formula. Ethyne, common name is acetylene. The common name is acetylene. Okay. Now let us go one by one. Just to see organic chemistry, alkyne. Today we will discuss only alkyne. Unsaturated hydrocarbon, general formula CnH2n. If I put N is equal to 2, this will be ethyne, carbon triple bond. If I put N is equal to 3, the name will be propyne, and this is the structural formula. 3 carbon here triple bond, and carbon valency 4 should be satisfied. And if I put N is equal to 4, then this will be C4H 4 to the 8 minus 2, that is 6, H6. This one is, as it is C4, the name will be butane. And if I put N is equal to 5, this should be C5H 10 minus 2, that is 8. 5 minus 2, 10, 10 minus 2, that is 8. This is pentane. If N is equal to 6, this will be C6 12 minus 2, that is, because 12 minus 2, 6 to the 12, 12 minus 2, that is 10. That is hexane. In this it will continue. If I put N is equal to 7, this will be C7 14 minus 2, that is 12. These series of compounds are called homologous series because in between two consecutive molecules, 1 carbon and 2 hydrogen less. Its name is heptine. HEPT, heptine, YNE. Last YNE. The suffix added, that is YNE. In this way, we can write so many compounds containing carbon triple bond. The first member of the series is ethyne. then the second is propine, third one is butane, pentane, hexane, heptane, like this will continue. Okay, let us go some more things about this. Let us discuss the physical properties of ethine, the first member of this series, that is ethine. Its color is ethine is a colorless gas. It has no color, colorless gas. Odor, it gives a sweet smell when pure, and impure acetylene has characteristic of garlic color due to presence of phosphine and hydrogen sulfide as impurities. That means in case of pure, the odor is sweet smell, and impure, garlic odor, garlic color due to presence of phosphine and hydrogen sulfide. Now come to solubility. It is almost insoluble in water. It is almost insoluble in water. It is soluble in organic solvent. Density, it is slightly lighter than air. Its vapor density is 13 and that of the air is 14.4. Boiling point, it boils at minus 75 degrees centigrade. Freezing point, it solidified at minus 82 degrees centigrade and liquefies minus 84 degrees centigrade. These are the physical properties you have to memorize. Next I am going to the chemical properties. The chemical properties, you see, first one is combustion. Ethine bonds in air with a luminous sooty flame to form carbon dioxide and water, liberating a large amount of heat. This is the reaction. The reaction is exothermic. As the heat is evolved, sooty flame is the high because of the high percentage of carbon which does not oxidize completely. Next one, addition reaction. Addition reaction means it gives a number of addition reaction. It is due to its unsaturated nature. The addition of reagent to an alkyne is completed in two steps. First step, one molecule of reagent is added to ethyne, that is alkyne, and its triple bond is reduced into double bond. Then double bond to single bond. First triple bond converted to double bond, then double bond to single bond. In this it will be breakdown. This is called addition reaction. Now see, the addition of the second molecule of the reagent then converts the double bond into a single bond, and thus finally a saturated product is obtained. Therefore, the addition reaction is called addition reaction. Now come to reaction with chlorine. Ethyne first adds on one molecule of chlorine to form 1,2-dichloroethene, 1,2-dichloroethene, double bond, or triple bond converted to double bond. Here the triple bond is reduced to a double bond. Now 1,2-dichloroethene undergoes further addition with chlorine to form a saturated carbon that is single bond, 1,1,2,2 tetrachloroethane. See, you see, tetrachloroethane. This is fully single bond. That means in this way, addition of chlorine means first triple bond converted to double bond converted to single bond. Next come to reaction with bromine. The addition of bromine to ethyne is similar to addition of chlorine to ethyne. Same process will get the addition product. If it reacts bromine, 1,2-dibromoethane will form. Again addition of bromine in the presence of carbon tetrachloride. Again double bond will break down to single bond. That is 1,1,2,2 tetrabromoethane. In reaction with iodine. Iodine reacts slowly with ethyne in the presence of alcohol and form 1,2-diiodoethene. First triple bond to double bond, 1,2-diiodoethene. Okay. In this I have discussed the reaction of chlorine, bromine, iodine, halogen group with alkyne, ethyne. Okay. Next you see addition of hydrogen. Addition of hydrogen, you see what happens. Ethyne adds hydrogen in the presence of catalyst like nickel or platinum on heating to form ethene, which undergoes further addition of hydrogen to form ethane. The triple bond in ethyne is converted into a single bond, as can be seen in the equation with structural formula. See, first ethyne, triple bond, addition of hydrogen in the presence of nickel with here centigrade, triple bond converted to double bond. Therefore, CH2 triple double bond. Again, addition of hydrogen, it will give single bond, that is ethane. Ethyne to ethene, ethene to ethane. Now come to reaction with hydrogen chloride. Ethyne react with aqueous solution of hydrogen chloride called hydrochloric acid. Ethyne adds on one molecule of hydrochloric acid to form chloroethene, which is also known as vinyl chloride. See, ethyne triple bond, addition of HCl, it will give vinyl chloride, that is CH2CHCl. One hydrogen is replaced, one double bond will be replaced by hydrogen CH2 and this chlorine will be here. This name is vinyl chloride. Now vinyl chloride undergo further addition with addition of chlorine to form hydrogen chloride HCl to form 1,1 dichloroethane. This is the totally breakdown triple bond to double bond to single bond. I hope it is clear for you. Let's come to the reaction with ammonical silver nitrate and ammonical copper chloride. See, silver nitrate and ammonium hydrate, what will happen? Silver acetate with white precipitate will be formed. Means when ethyne is treated with ammonical silver nitrate solution, this is silver nitrate Ag, NO3, metal silver or copper replace hydrogen atoms of ethyne to give a white precipitate of silver acetylide and a red precipitate of copper acetylide. In case of copper, this will be red, and this is silver, means this will be white precipitate. Silver nitrate, you will get silver acetylide, white precipitate. In case of copper chloride, you will get copper acetylide, red precipitate. This is red precipitate, this one is white precipitate. In case of silver, this is white, and in case of copper, it will be red precipitate. Okay. You have to memorize this type of reaction. These are the chemical properties of ethyne. Okay. Thank you for today's class. Later do more.